So on this question, we are given part of our renewable energy systems. A solar plant uses panels with dimensions 2,2 by 1,2. That's a rectangular panel. So we can obtain the area from there, 2,2 by 1,2, which is going to give us an area of 2,64 square meters on a what? On a cycle with 2 megawatts output power. So we have an output power for that cycle of what? 2 megawatts. So that's 2 megawatts. The annual energy output of the plant is given in gigawatt hour. The annual for 365 days. The annual is given as what? As 18,25. This is gigawatt hour. The efficiency of the cycle is given. So remember, we've got the power for that cycle, and we also have the efficiency of the cycle of what? 0,32. The total available panel area, panel area being this one in square kilometers. Remember, we have the area of a single panel here in square meters. So let's have the total area in square meters. 1 square kilometer is actually 1 times 10 to the exponent of 6 square meters. So we simply multiply by 10 to the exponent of 6, which was going to give us 13,738 square meters. That's the total available panel area for that panel. This is what our total area. So the question was to determine the following. 6.1. We wanted to determine the plant's solar power in megawatts. The plant is what? Solar power. The total, this is like for the whole plant, the solar power. So remember, they gave us the output of the power and there is efficiency. So the solar power can be determined, which is the input. In this case, the solar is the input. So we have the output. From there, we can calculate what? The solar power. So 6.1, we can have the solar power from where? From the cycle efficiency. Remember, we talked about the cycle efficiency from our notes here. I think I gave you those calculations. Didn't I, guys, about the cycle efficiency? The cycle efficiency here, right? We just talked about the PR value and it ended, no, yeah, the cycle efficiency P out, which is the AC over the P solar, which is the DC. So you can have it from there and calculate our solar power. So that's from our cycle efficiency. It's simply going to be P out over P solar. So that's for the solar. If we make it the subject, we're going to divide by what? The cycle efficiency. In this case, we're going to simply divide by what? By the cycle efficiency. So in megawatts, you're going to use the output in megawatts. It's already in what? In megawatts. So we're going to have our answer in what? In megawatts. So divide by what? 0,32, our cycle efficiency. That was going to give us 6,25 megawatts. So that is it. Basic from what we're given. It was basically like that. All right. Then the time the plant operates in hours per what? Per day. We need the time in hours per day. We have the power. All right. Remember, power is from where? Power can be taken when we have energy and time. If we've got energy and time, we can have the power here. Energy and time. So you can have the time from there. All right. So that's we simply need. All right. Because here we calculated the one of the solar, the power of the solar. We have this one, the power of the solar 6,25 megawatts. So to obtain the time the plant operates, we can calculate it from what? From the power of the solar. From the what? Power of the solar. Because the power of the solar is simply going to be E over what? The time. So that is what we have. So we have the total value. The E is there and the time is there. So, I mean, the time is the one that we need. So the time is going to be E over what? The power of the solar. Take note, it's per day. This E is taken for what? 365 days. Our E is taken for 365 days. So to have our time per day, so let's adjust here and say what? Our time per day. We are going to adjust our formula and divide here by the number of what? The number of days. To have per day, we must consider the number of days on our calculation. So that was the consideration. So E is in what? Gigawatts per hour. So let's just rewrite. Giga is times 10 to the exponent of 9, 18,25 times 10 to the exponent of 9. The power of the solar, we have it megawatts, so that's 6,25 times 10 to the exponent of 6 times the number of days yearly or annually is what? 365 days. So that will give us the time per day. This one is going to be per day because we divided by the what? The number of days. So that was actually the consideration that you're going to have, and that was going to give us 8 hours per what? Per day. So we've got the time of operation, the time that the plant operates per what? Per day, 8 hours per day. Then the number of what? The number of solar panels the plant uses as a whole number, the number of what? Solar panels. Remember, for the number of solar panels, you can have it from different calculations depending with what you have. If we have the power from the PV system or from the total area, depending with what you have. So here I can take advantage of the total area because I have the total area of the panels and the area of a single what? And the area of a single panel. All right, sorry for that. So this can give us what? The number of solar panels. So the 6.3, the number of solar can be taken from the total area over the area of each panel. The total area 13,738 in square meters, and the area of each panel in square meters is what? 2,64. So that is going to give us the number of panels, which was 5,203,738, something like that, which you can round off to the next whole number. The whole number is this one. So the next is going to be 5,000 and what? 5,204. This is going to change into 4. So those are the number of panels that you're going to have. So you see, it's all about what you're given, the information that you're given. Play around with that information. That is how we can answer these questions.